Welcome to episode 14 of EV Society's Canada Talks Electric Cars webinar. And thank you for visiting our YouTube channel. All of our previous webinar episodes are available here for your viewing pleasure. My name's Tim Burrows, and I produce and do my best to moderate this monthly webinar. This particularly popular episode features Mr. Sandy Monroe of Monroe and Associates. I had prepared a thorough, glowing introduction for Sandy, but prior to broadcast, he asked me not to use it. He was more interested in getting down to business so that he could share his thoughts and then take as many questions as possible from the audience. He is famous for his lean design methodology, and I believe he displayed a little of it with us in real time. Of all times for Murphy's Law to show up, it certainly did with this episode as we went live. Specifically, a glitch caused the episode's recording to fail. The good news, with the help of Zach Tiley from Sandy's technical crew, most of the audio was recovered and we were able to have it synced with Sandy's slide presentation. The only piece missing, unfortunately, is the Q&A section at the end. Nino DeCara, president and founder of the popular Electric Autonomy Canada website, did a splendid job taking Sandy through audience questions. We thank Nino, and we regret that this segment could not be recovered for the YouTube. Okay, Sandy, I'm going to pass things over to you.
Hey, Tim, thank you so much for inviting me. I hope everybody can get something good out of what I'm going to talk about. I will tell you that I'm going to move a little bit beyond just solid state batteries. So I mean, let's get into it, and so we can make something happen here in a hurry, so everybody gets a chance to maybe ask questions. So here's my bio. I've done lots of stuff, and in June I was the cover story on automotive engineering from the SAE. Next one. So who is Munro? We have two operations that we have here in Auburn Hills, Michigan. We're a little bit about 25 miles outside of Detroit. We have a 47,000 square foot building, and mostly what you're going to see is that. And then we have a $60,000 square foot building that we use for one specific customer that chooses not to be named. That 60,000 square foot building is basically used for new product development. Next one. If we look at this is kind of what goes on inside there, and so those little cubbies are on the outside. It's got all of the things we needed to know about as far as getting the job done, what the marketing people and whatnot want, different statistics and whatnot that we need from the market that we're trying to tag into, and then of course the customer's needs and wants are also up there. Next one. This is one of the products that we worked on extensively. This is Motor Trend's Truck of the Year for the last 3 years. And it's also in 2020, it was Luxury Car of the Year. Not very often you hear about pickup trucks becoming luxury, and I made car. It's Luxury Vehicle of the Year. So at the end of the day, we see a lot of product, whether it's good, bad, or indifferent. And what we see coming down the pike is a movement, if you like, toward EVs. Next one. So Zeta, the group that kind of is keeping track of what's going on, is saying that public opinion has turned against ICE. And that public opinion, in essence, is coming from people who are 14 to 16 years old. And they're thinking about what they want to have when they decide to buy a mode of transportation. The next one. This is my assessment of what things are going to be looking like, I should say, in 2028. I used to say 2030, but I think that 2028 is going to be the big deal. So if we look at North America, and this is Canada, United States, and Mexico, I'm looking at about 55% is going to be EVs, 20% is probably going to be HEVs, hybrids, and we got about 25% that's still going to be ICE. If we look at Europe, 80% I believe is going to be what's happening there, 15% for HEVs and 5% ICE. China is its own entity, and I'm starting to think that they may move faster, but EVs about 70%, HEVs 10, and ICE 20. And the only reason for the ICE being as high, being 20%, is because of the western provinces in China. It's a desolate kind of a place. There's only one way to get in and out, and that would be with diesel. And then we've got Japan, South Korea, 75, 15, and 10. So what does a global assessment look like? Next one. So from a global standpoint, if we exclude Africa, the Middle East, South America, and India, where the data is very, very difficult to accrue, but it does include Australia and most of the first world type of countries. I think we're looking at EVs being at about 70%, HEVs being at 25%, and ICE at about a nickel. So we're really and truly seeing a rapid movement. And although I have a lot of arguments with a lot of the prognosticators, I think I'm probably going to be right, because quite frankly, in 10 years, the world went from 50-50, this would be in about 1908, 50-50 between ICE and EVs, to absolutely no EVs at all in North America being built. So I believe we're going to get into that type of a market. Next one. If we look at North America and we're looking at batteries and stuff like that, you can see really there's not a heck of a lot going on in Canada. Not that has made the news anyways. The two big ones are the guys at Blue out in Montreal, and then we have the Windsor-Essex initiative, which hasn't quite gotten started as far as I can tell yet. Canada needs to move a lot faster, and I will tell you that there are some contributions that have been made that have been very, very significant. A lot of Tesla's R&D is done up in the Toronto area, and I think that you're going to also, if you haven't maybe you've heard up there, but most people in the States did not hear about this next one. Next one. So the Canadian EV contribution here. Canada startup Spring Power International sold several patent applications to Tesla for $3. This $3 investment that Tesla made is going to be bringing them huge dividends, because we are pretty certain that the key element in making the 4680 battery is the contribution that Spring Power has made, because Spring Power's website kind of like goes up and down a lot, and exactly what Elon Musk had said during Battery Day about the electrolyte they were using is pretty much what Spring Power International sold to them for $3. These patents will help to reduce the cathode production cost by more than 75% by reusing water from the production. This is a gigantic deal. So things are happening, but unfortunately they're happening quietly, and the rest of the world doesn't really understand what's going on. Next one. Today what I want to do is I want to look at what are the really big things that are coming down the pike here. So I'm a little crystal ball, and I have a bunch of different things. I think that there's going to be EV leaders that are going to emerge from the pandemic. We still have restrictions all over the place, but there are some leaders that are taking full advantage of what's going on. Others, not so much. I believe that there's going to be innovative design shifts that'll involve ADAS, automatic drive systems, growth of mega castings, new battery technologies. Semi-solid state I'm going to talk about a little bit. Then there's solid state, and then there's also hydrogen. Then I want to talk a little bit about VTOLs, vertical takeoff machines. This is where I think that Canada should be also moving ahead in the quickest possible way. So let's talk about those leaders. I met one leader that is definitely bold, and he has a Canadian connection. He still retained his Canadian citizenship. Elon Musk. I spent I don't know, 4 or 5 hours with him at SpaceX in Brownsville, Texas. He's quite an interesting guy. He's the richest guy on the planet, and yet he talks and acts like a normal human being. I guess the really interesting part is that he is an engineer's engineer. This guy really knows his stuff. And I watched him sitting in a meeting with a bunch of other engineers talking about a rocket engine. So he knew that I had worked on rocket engines in the past, and he asked us to stick around. I made a couple of suggestions, so did he. And his team of about 25 people, and this is, by the way, around 10 o'clock at night in Brownsville, Texas, so that's an hour behind us, hour behind us. That's 11 o'clock in Toronto time, and he's still out there with his team. Myself and Corey, we couldn't take it. We had to leave. This guy is really the type of person that all CEOs should try and emulate, but he's not the only leader out there. Next one. This is the guy to keep your eye on. Chairman Xi has more money and more ambition than Elon Musk. I have met this guy as well, and he's definitely a nationalist. He wants to make sure that his country is going to make out and come out on top. He got a mandate to hang around for quite a while, and I think that anybody that takes a look at him and says, oh, just another Chinese guy, is completely out of his mind. Next one. I believe that China will dominate EVs for a decade. Chairman Xi has announced China will be in the endeavor to reduce carbon emissions to reach carbon neutrality by 2060. He's already modified that. I do have a small operation in China, and the new number is 2048. China wants to be 75% EVs by 2030, 100% EVs by 2035. And by the way, when they talk about carbon neutrality, you have to remember they burn nothing but coal. They have a lock on it. Australia mines coal for them exclusively, and they burn all of it. And if you get into Beijing on a bad afternoon, it's so smoky and horrible you can't see. Literally, this is not figuratively. This is literally, you can't see your hand in front of your face. He wants to clean up his country, and he wants to totally stop the manufacture of ice by 2040. So that's kind of what I see as far as leaders. Let's move on to the next one, and that's the innovative design solutions that are going to evolve into what we're going to see in the future. And the first one is ADAS, automatic drive system. So let's have a look at what's out there. Next one. So Tesla has autopilot, Audi has Delphi, then there's Mobileye, Luminaire, Velodyne, Innoviz, and then the last one there is Teledyne FLIR. We're going to go real quick. One, I don't care about Tesla. Next one. Next one is Audi. I don't care. Next one. Mobileye, waste my time. Next one. Luminaire, I don't think so. Velodyne, no. And in Innoviz, nah, it's not going to happen either. So now we are at Teledyne. And why am I saying FLIR is the way to go? FLIR stands for Forward-Looking Infrared. I work on a lot of military products. Some of them are Canadian, Most of them are US, and a couple of them were British. FLIR is the only way that I can make a missile go from here to there and actually hit its target. None of those other things work. If we look into what I see as the future, it's not going to be a traditional way of making things happen. If you look over at the lower right-hand side of the page, you'll see that there's a bunch of different ways that you can make things happen as far as FLIR or cameras or thermal detection or on and on. But I want you to watch what happens when we look at full night vision FLIR. Next one. Have a look at the one on the left-hand side where it says night vision imagery. And you can see a ghostly image of some guy with a hat on. Then you look right next to it, colorized FLIR. You can read that guy's jacket. You can see that his jacket and his t-shirt are different colors. You can actually see his face. If you look at right to the right of it, the 7 Magic Mountains in Las Vegas, one in daylight, the other one at midnight. This is the way to go. You will never have a problem detecting what's going on. Seeing in color is what the human body is used for. That allows us to mentally process what we're seeing much, much faster. And that difference between basically those ghostly greenish images, or sometimes orange, and full color FLIR, that's the way it's going to go. Like I said, I wanted to get as much as I can possibly get across to you guys so you can start looking at what the direction is that you might want to get into if you happen to be a manufacturer or an inventor or whatever. Don't waste your time with cameras. Don't waste your time with LADAR or laser or radar. It's just it's a waste of time. This is the way to go right here. Next one. So the next one I've got down here is the growth of mega castings. Okay, so mega castings. Next one. Mega castings are what Tesla has done to basically come up with a 3-part lower platform. What you're looking there on the upper left is 3 gigantic castings. One is the entire rear, one is the entire front, and the center section is going to be where the batteries are going to go, the 4680 batteries. This idea is not new. For 15 years, I've had one of these things sitting in the back of my factory here, and for 15 years, engineers walked right by it. Oh, that can't work. This is, there's only 2 ways to make, you only have 2 choices for volume production. One would be high pressure die casting, which is what Tesla's doing, and that basically cuts about a third of the body plant assembly system and about 50% of the labor. If you look on the bottom, you'll see injection molding. And if you watched our little video, you'll have seen that we've created, with SABIC, a new battery tray that probably could work inside of the VW ID4. That sort of thing is the only other way to make things happen. The old days of stamping out little teeny pieces and welding them together, those days are numbered. So let's find out what we need to do in order to make that happen. Next one. So Ricardo Ferrero from Hydra, he said on March 16, 21, we've been able to secure the first order for an 8,000-ton die casting machine. That's a big machine. That's bigger than anything that anybody has, period, anywhere. So, next one. So what does that mean for everybody else? When Tesla comes on and says, oh, we got the first one, we like it. We'll have 12 more, please. That strategy of strangling everybody else out of the market is way beyond the normal checkers game that a CEO would play. This guy, he's looking real hard at what he needs and how he needs to do it. By the way, the other thing you should know about is that there's a second company in the world that can make an 8,000-ton die casting machine. And that company is in China. And they've just been given, I don't know how many orders, but a lot of orders to make some of these 8,000-ton die casting machines. Next one. So why is everybody doing that? Because the piece cost drops like a rock. Because it's also going to reduce the weight. And weight and range go hand in hand. Actually, the other thing is that there's a huge reduction in the amount of investment costs. I only have to buy two die casting molds for each one of those areas. So I have to buy 6 die casting molds. The floor space needed for those is 1/3 the size of a normal site. That's a big deal. And how many people am I going to need? Well, when the mold opens, and I have videos on this, when the mold opens, it actually rips free all of the gates and sprues and runners, and it goes bang, 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 and it basically is picked up by a robot and put onto a finishing line. Think of the 50 or 60 people that normally would be in that same sort of an area. And by the way, that's times 3. That's the kind of thing that you're looking at to try and reduce cost. This is a huge difference, huge. So let's have a look at battery technologies. Go to the next one. So I'm going to talk a little bit about what I think is the biggest players and the biggest plays in the battery industry. So we're going to talk about semi-solid state batteries, solid state batteries, and then solid state hydrogen. But before they do that, let's take a little look at what's out there right now. So here's the bets that people are placing. One is the 4680. This is the one that Canada's had a little bit of a helping hand with. This is Tesla's biggest bet on their next generation for all future products. The Cato Road facility is the pilot, but I believe that all the gigafactories will eventually go to the new 4680 direction simply because it costs so much less and it does so much more. I believe that the 4680 is going to win hands down. If we look next to it, we look at solid state. There's a lot of big bets here. I've interviewed a number of different people that have got solid state batteries. Anyway, there are a lot of big bets. VW, Mercedes, Fords, and others are betting the farm on a technology that's been unsuccessfully worked on since 1920s. Why? Because the upside's vast, but it's really hard to scale up. Think of trying to glue potato chips together with 2-way tape. It's a tough row to hoe. Then we've got hydrogen. This is the most plentiful element in the universe, but why is it so hard? Hydrogen has been the power of the future since its discovery by Robert Boyle in 1671. Although it's plentiful, it's attracted to other elements, and once attracted, it sticks like a blood-sucking relative. I thought that was a great way of putting it. And actually, at the end of the day, hydrogen's wonderful, but there's got to be a better way of making it happen. So I'm going to talk about solid-state hydrogen. Next one. So now we're looking at a 3D printed 4680 that was made by one of our viewers named Fred Jessup. This is a great idea, and I'm going to tell you why in a little bit. But for right now, just suffice to say that this thing is what I think the wave of the future. Next one. So why does why does Monroe use Tesla's example so often? And the reason for that is because Tesla thinks ahead. Okay, so the Canadian startup company Spring Power sold some patents for $3. That $3 investment is, I can guarantee you, is much more than $3. And I can see a ton of things happening with Spring Power and the people in it. I think that maybe they sold those patent applications for $3, but I think that they've landed themselves the best job on the planet. So what is Tesla doing? You can see that ultimately in 10 years, they want to have a terawatt hours of battery production. 10 terawatt hours. That's an absurd number. No one's going to be able to catch that up. So let's have a look at the competition here. So let's move to the next one and talk about solid state potential benefits. So if I can get this thing to work, I can get charge in 10 minutes, full charge in 10 minutes. So maybe 100 kilowatt hours in 10 minutes. I can increase my energy density from 2 to 8%. My range will go from 500 to 800 kilometers, 300 to 500 miles. Almost the same weight. I can store 1 kilowatt per liter. That's 4 times more than what Tesla can do on the Model 3. And then it's non-combustible, and if you can get it to work at a low temperature, and it has the minimum use of toxic materials. So there's 2 of these things that are sitting out here in the market. Next one. Scape, which I had a look at, it runs at room temperature, but it's not solid state. It's a semi-solid state. It still has an electrolyte. It's a little bit of an electrolyte, but it's still an electrolyte. If we look at the next one, we can see all of the wonderful things, and you guys you'll get this if you want it, the presentation. Look at all the wonderful things that can happen if we can get the solid state batteries that QuantumScape is making right now. If we can make those things happen, look at all the good stuff. That's all great, but it's still not a real solid state battery. Let's talk about who does have a solid state battery. Next one. That would be LMP, lithium metal polymer. And that's basically a Quebec operation called Blue Solutions. They linked with Valore from France, and they combined their 1,700 patents to form a new company. Now, why do I like this? I like it because it's really solid state. Why don't I like it? Because I have to heat it to 80 degrees C in order to make it work. That sucks away some of the excitement, and it costs a lot of money to make that happen. Next one. So who's using it? Well, Mercedes. Mercedes has got their buses running them. They have 12 hours of life, then they get swapped. It gives 23 hours of full service, takes 1 hour to swap the battery packs out and put the new ones in. This is getting 23 hours out of a bus, that's like staggering. That's way better, way better than any diesel bus ever. So if you're thinking of buying buses, you might want to consider this Mercedes bus here. So let's compare the facts as I know them right now. Next one. So if we look at year 2021, solid-state batteries are still in the experimental stage, and Tesla's got 10 gigawatts of power at the CADA facility. If we look at 2022 to 2025, solid-state battery companies are in the prototype and, or semi-solid-state batteries are at the prototype and refining stage. They may be able to get from 100 to 900 gigawatt hours. So we look down and we see 2025, limited start of production, 1 terawatt hour. That's not enough. Then we look down here at 2030. Full start of production, okay? And Tesla's saying, well, I want to have in 2030 3 to 4 terawatt hours. How's anybody going to catch up? How? It's not possible. So we look at Tesla as in a different light because I want to look at it in a reliable way. The next thing is, are batteries the real key to range? Well, let's just have a look at the next slide. If we look here, you can see I've got the Tesla Model Y, the 2021 Ford Mustang, the 2021 Volkswagen ID4, and we've got the 2021 Audi e-tron. If we look at what kind of mileage we're getting out of the Model Y, next one. So let's look at first off the kilowatt hours we're getting out of the Tesla Model Y. That's got a 75 kilowatt hour battery. The next one is the Mustang, 88 kilowatt hours. Volkswagen, 82 kilowatt hours. And then from the Audi, 95 kilowatt hours. Next one. But look what happens. The guys with the biggest batteries wind up with the lowest number of miles per gallon. Why is that? Let's look at something that again doesn't make sense. Next one. If we look at this slide, which we've shown already, actually it was shown a couple of days ago, you can see that battery weight, battery capacity, and driving range don't seem to have much in common, especially when you look at the Jaguar at 600 kilograms of batteries and the Audi e-tron with 700 kilograms of batteries, 90 kilowatts and 95 kilowatts, and my God, they're beaten by the Chevy Bolt. This kind of stuff is just, to me, is just staggering. People forget weight reduces the range. Friction reduces the range. And aerodynamics reduce the range. There's a whole bunch of other things like how much wire have you got inside. That'll reduce the efficiency. What type of software have you got? A bigger battery means nothing. Nothing. Efficiency with the whole car, that's what we need to look at. So as you start looking at things, more and more, if you're doing an analytical job like we are, more and more you're seeing we need to move further and further away from people we would have thought knew what they were doing, like Jaguar and Audi and BMW and Mercedes and on and on. These guys haven't quite caught on. Next one. So let's talk about hydrogen. Yes, yes, hydrogen is still one of those things that people think of like the Hindenburg with. But what if we had a solid state hydrogen? Okay, so there's a company, a little company, that invented solid state hydrogen. In other words, they've got a little disk that has a nanostructure of deposits that gives us the ability to pull hydrogen and basically make it usable inside of a fuel cell. Next one. Now, you can have one of these little containers, like that little teeny picture in the upper left, or you can have a block of 4, and that's the bigger picture on the left, or you can have this bank of these little disks flying around. Now, I'm not a fan of putting hydrogen into a car. To me, it's like goofy. It doesn't make enough sense because, quite frankly, a fuel cell will never wear out, but it's costly for the initial buy. This is a good application for Class 8 trucks, stationary power, aircraft, a lot of things, but not necessarily cars. Next one. The next one is basically how you get in touch with these guys. Plasma Kinetics is the name of the company. The guy's name is J.R. Sung. He's their chief of sales or chief of business. I can't remember. Anyway, this guy here is looking for people to invest. And I don't make many calls for people to. I don't have any stake in this, by the way. Next one. But I think that Toyota needs to go and think about getting involved, because Toyota has the best fuel cell on the planet. At 1.3 volts per cell, nobody has anything like it. And I worked for Ballard, an international fuel cell, and a lot of other places. We never got anywhere near that. Next one. And so the last thing here is VTOLs, vertical takeoff and landing machines. So why do I think that vertical takeoff and landing machines is a good idea? Next one. Because, quite frankly, the speed and convenience. This is the George Jetson. I mean, you can take off from your driveway, fly to wherever you want. You don't have to go near any congested traffic. You have 1,000 feet of separation between you and anything else. And if you're in a car, you have 3 feet of separation side to side on either side. And maybe, if you're lucky, you get a couple of car lengths front. And who knows what's in back of you, because no one looks in the rearview mirror. So I believe that in this COVID environment, personal space is at a premium. Everybody wants to get out and do things, but nobody wants to be too tight. I think that for air cargo and for last mile delivery solutions, there's nothing better. And for emergency response, why would I want to get into an ambulance that could get stuck in an accident, or worse yet, stuck in traffic? And then the last one, how much money can we spend on new roads, especially after all the money that's been pumped out and into the marketplace for people who aren't working? I think we're in for a real big surprise as far as electrical bills, because somebody's got to pay for the new roads. And I think that if you've got a VTOL, you're not going to be needing it. So who else thinks that I'm right? Next one. Well, how about Hyundai? See that fancy box right there? That's their long distance air cargo scenario, and that's coming up here real fast. 2026, they intend to have this thing running and operational. By 2028, they intend to have an urban air mobility unit. This is a big deal. These guys are really playing it for keeps. Now, there are other companies that have, done something or says they're going to do something. GM, Ford, BMW, definitely the guys in Japan. But Hyundai is the only one that's got full-page ads on their VTOL ports and things like that. So I believe that we're going to see a lot of changes, and VTOLs is definitely one of them. So with that, next one, thank you for your time. Carpe diem. Go and seize that day for tomorrow. And I'm only 9 minutes late. So anyway, thanks very much, and that's the end of the show.
I'd sincerely like to thank Sandy for bringing us up to speed about solid-state batteries and a whole lot more. I know I speak for all of our members and guests when I say how much we enjoyed the presentation. So join us next month on August 3rd at 7:30 Eastern Standard Time for another episode of Canada Talks Electric Cars webinar. Our guest next month will be Dr. Nathan Lemfers. Nathan is a postdoctoral fellow at the Smart Prosperity Institute. His research examines the politics and policy of electric vehicles in Canada and the impact that this new technology will have on regional economies. So thank you very much for watching our episodes. From all of us here at Electric Vehicle Society, and until next month, please stay safe and healthy. This concludes our webinar.